Welcome, my dear students. So, in the previous lectures, we have discussed about the concept of a real sequence and its convergence. Okay, so in this class, we will be discussing more about the concept of convergence in general. So, that's what we have to be more focused about. So in the previous class, we have discussed about the concept of convergence. Okay, so a sequence which is denoted as xn is said to converge to x. This is the notation for that, where x is called the limit of a sequence. So the concept is that after a certain stage, every term of the sequence should be nearer to x. So in that sense, we have defined that for every epsilon greater than 0, there exists a natural number k such that our definition was modulus of xn minus x is less than epsilon for all n greater than or equal to k. This was our definition. So from this definition, we can state somewhat equivalent conditions for the convergence of a sequence. So, which gives you more insights regarding the convergence as a general concept. So, this is what we are going to use. So, we are trying to find equivalent conditions for convergence, which is essential because we only have a definition for establishing the convergence of a sequence. We need more insights from that itself. So that's why we need more conditions. Before moving on to that, I'll just remind you what is an neighborhood, epsilon neighborhood. We have already discussed this. An epsilon neighborhood of a point x or u is denoted as v epsilon u. Okay, which is the epsilon neighborhood of u, which is the collection of all points such that modulus of u minus x is less than epsilon. In number line terms, we have a line, we have a point u, this is u plus epsilon, this is u minus epsilon, then the interval, this interval, all the points in between this interval is called the epsilon neighborhood of that point. So keep in mind this thing. So in our terms, in the sequence convergence terms, this should be an epsilon neighborhood of x. So keep that in mind. So we have enough tools to define our equivalent conditions. So this is what we are going to establish. We are going to establish an equivalent condition for convergence. So the statement of the theorem is, our theorem states that let xn be any sequence, real sequence, meaning that all the terms of the sequence belongs to real number. Then the following conditions are equivalent, meaning they are same. You can replace one condition by another condition. First condition is xn converges to x. Okay, or xn is a convergent sequence. This is equivalent to, for every epsilon greater than 0, there exists a number k belongs to n such that modulus of xn minus x is less than epsilon for all n greater than or equal to k. Okay. This can be obtained from the definition itself. Xn converges to x means for every epsilon greater than 0, there exists a number k such that modulus of xn minus x is less than epsilon for all n greater than or equal to k. Now we are moving on to the third equivalent condition, which is clearly from this. For if this condition holds, or the condition 2 holds, or condition 1 holds, then we can say that xn belongs to what? X minus epsilon, comma, x plus epsilon for all n greater than or equal to k, or x minus epsilon less than xn less than x plus epsilon for all n greater than or equal to k for a given epsilon greater than 0. So that is, for every epsilon greater than 0, xn should be in between x minus epsilon comma x plus epsilon. This can be easily obtained from this statement because we know that modulus of xn minus x is less than epsilon, meaning minus epsilon less than xn minus x less than epsilon. So now we add this x on to both sides, we get x minus epsilon less than xn less than x plus epsilon. Okay, so modulus of xn minus x less than epsilon is equivalent to saying that x minus epsilon less than xn less than x plus epsilon for all n greater than or equal to k. That is what we have established. So a sequence xn converges to x is equivalent to saying that for every epsilon greater than 0, there exists a natural number k such that modulus of xn minus x is less than epsilon for all n greater than or equal to k. If you replace this by the definition of modulus, that is modulus of xn minus x is less than epsilon, imply that minus epsilon less than xn minus x less than epsilon, which imply that x plus x minus epsilon less than xn less than x plus epsilon for all n greater than or equal to k. So this statement is equivalent to saying that x minus epsilon is less than xn less than x plus epsilon for all n greater than or equal to k. So this is the third statement or third equivalent statement. Now we are moving on to the fourth equivalent statement. So x minus epsilon less than xn less than x plus epsilon, which means that if you take a number line, this is x minus epsilon and this is x plus epsilon. Okay, the term xn after n greater than or equal to k, that means xk plus 1 etc., all belongs to this interval x minus epsilon comma x plus epsilon. We have already defined that an epsilon neighborhood v epsilon of u should be the collection of all points x such that u minus epsilon is less than x. That is, if the points is in between u minus epsilon comma u plus epsilon, we can say that the points are in the epsilon neighborhood of u. Here the points xn belongs to x minus epsilon comma x plus epsilon, which is what we called the epsilon neighborhood of x, that is v epsilon of x. So what we have established is that xn belongs to v epsilon of x for all n greater than or equal to k, which is clearly from this statement. X minus epsilon less than xn less than x plus epsilon for all n greater than or equal to k. The interval x minus epsilon comma x plus epsilon, this interval x minus epsilon comma x plus epsilon is denoted as v epsilon of x. So xn belongs to what? V epsilon of x for all n greater than or equal to k. So xn converges to x implies for every epsilon greater than 0, there exists a natural number k such that modulus of xn minus x is less than epsilon for all n greater than or equal to k. So this is, so 1 implies 2 by definition. Okay. So these are the four equivalent conditions. The first condition implies the second condition by the definition of the convergence. And in the second condition, you replace this part, that is modulus of xn minus x less than epsilon, by the definition of modulus, that is minus epsilon less than xn minus x less than x epsilon, which from which we add x onto both sides, that is x minus epsilon less than xn less than x plus epsilon. So what we get is x minus epsilon less than xn less than x plus epsilon for all n greater than equal to k for a given epsilon. This is the third condition. So we can easily obtain 2 implies 3 by simply putting modulus of x1 minus x by the definition of modulus. From that, if xn belongs to x minus epsilon comma x plus epsilon, the interval x minus epsilon comma x plus epsilon is termed as v epsilon of x or epsilon neighborhood of x. That means xn belongs to v epsilon of x for all n greater than equal to k. From this implies 3, equation 3 implies 4. Okay, so from this 1 implies 2, 2 implies 3, 3 implies 4. Then 4 implies 1 can be easily defined or understood. Here xn belongs to v epsilon of x means modulus xn minus epsilon comma x plus epsilon, xn belongs to this interval, from which we can say that x minus epsilon less than xn less than x plus epsilon for all n greater than equal to k, from which we can say that modulus of xn minus x is less than epsilon for all n greater than equal to k, from which we can say that xn converges to x. So 4 implies 1 as well. Okay, so these are the 4 equivalent conditions for convergence. So we can easily understood the convergence by a better means. That's what we are trying to establish. A sequence xn converges to x means that every term of the sequence is in between x minus epsilon comma x plus epsilon or some epsilon neighborhood of that point. So another intuition from this point is, here we have established that xn belongs to this interval x minus epsilon comma x plus epsilon for all n greater than or equal to k. That means xk, xk plus 1, xk plus 2 and so on. All the terms belongs to the neighborhood what v epsilon of x. So all the only terms which does not belongs to this interval are v1, v2, etc., vk minus 1. These are, so v naught, x1, x2, so sorry, comma, xk minus 1. These are the only terms which does not belongs to this interval. Okay, so the only terms which does not belongs to this interval are x1, x2, etc., xk minus 1. So which is a finite number of terms. Okay, so a sequence converges means except for finite number of terms, all the terms should belongs to some interval of the point or the limit or some epsilon neighborhood of the limit. So you can understand the convergence by means of this as well. So a sequence xn converges to x means that all but finitely many terms of xn is in some neighborhood of x. This is what means. All but finitely means except for finitely many terms, that is x1, x2, etc., xk minus 1, all the terms of the sequence should belongs to the epsilon neighborhood of the point x. This is what the concept of convergence actually means. Hope you understood. We can discuss this later. Thank you.